This meeting is being recorded.
Okay, guys, so we are finally going to get into a little bit of math magic. Okay, so today we start to talk about a new way to solve systems. So far, we've graphed them, looking for an intersection or comparing their slopes. In the event that they are the same, we have to check the y-intercept to see if they're going to be parallel or the same line. And then yesterday or in our last video, we solved by substitution. Okay, so we had to isolate one of the variables, X or Y, and then substitute for that variable into the other equation. All right, so today, okay, we're still in unit 5. And today's method is going to be called elimination. And that's day 1. Okay, so elimination day 1. And so to set this up for us, we kind of just have to explore the relationship of equations. So for instance, right, if I have x equals 7, right, and then I said, well, what is 2x equal to? Most of us quickly would say 14, right? And then I could say, well, what is 5x equal to? That would be 35. And then lastly, we could say, what is 8x equal to? Okay. And here's the fun part. Okay, and this is where this is going to go for us. It's true we could take 7 and multiply by 8. Okay, but the other side of things would say, right, if I just add those, right, because 1 plus 2 plus 5 is 8, then 7 plus 14 plus 35 must be my answer, which is 56. Okay, so that's the neat part of this method, is we can exploit this fact, right, that we can add and subtract equations from each other to get what we wanted. Okay, and the same thing would be true if you were to subtract these equations. So if you said 5x and 2x, right, what is 3x? So if 5x is 35 and 2x is 14, and you subtract those two, then 3x has to be 21. Okay, and that's without substituting for the x to solve at ever, right? So we're going to exploit this fact. Okay, so elimination is, okay, a method of solving systems by adding or subtracting the equations to isolate a variable. All right, so that is elimination, right? We're going to add or subtract an equation to isolate a variable. Okay, so let's look at a couple of examples. All right, so example number 1. Now we're going to get, this is day 1 because day 2, it gets a little bit different. Okay. I guess I should start by saying, okay, let's go ahead and write this example down and then we'll explain. So x plus 4y equals 13 and x minus y equals 3. All right. So, right, highlight number 1. The equations must be lined up. Okay. And so what do I mean by lined up? Well, the equal signs have to be on top of each other. Okay. So you can see these two, the constants, the y values, and the x's. Okay. It can be in any form. The equal sign can be anywhere. The x and y can be anywhere as long as they're on top of each other when you do this. Okay. So it could be, we could rewrite this system to say x equals negative 4y plus 13. And that equal sign would be here, right? This would be x equals y plus 3. And there would be still lined up, okay? So we'll look at a couple different situations where maybe they're lined up a little differently. But when I look at this system, okay, I have to decide, right? I have to think about, do I add or subtract? Okay. So if I look at this, right, and I want to get rid of a variable by adding or subtracting, I notice that the two x values are the same, right? We have 1x here and 1x here. Positive 1, positive 1. In which case, right, I would choose to subtract the two equations, okay? So if I subtract, right, 1 minus 1 is 0. So you had 0x, it goes away. And then I have 4 minus negative 1. 4 minus negative 1 is 5, okay? So 5y. And then I have 13 minus 3, which is 10, okay? Which leaves me at y equals 2. And now that I know y equals 2, all I have to do is substitute in to one of my equations, right? Now this was added, so when I substitute, I'm going to ignore it, right? I didn't change the values of everything. I just subtracted them from each other. So if I choose to substitute in the second one, it's still x minus y equals 3, okay? But we can put it in the top and it's all the same, right? 4 times 2 is 8. That would be 13 minus 8, which means x must be 5. Okay. And there's my solution. Okay. So this is one of my preferred methods only because it's so efficient. And it lends itself later on to another method of solving, which we may or may not get to, but we'll see. Okay. 3x plus 4, and then y equals x minus 2, okay? So again, they have to be lined up. Your y has to be on top of your y. Your equal signs have to be in the same position, 3x and x, and then we have our constants at the end. In this case, right, I can see, right, I have one y and one y, so again, I'm going to choose to subtract. Subtracting these two, right? Y minus y, that's 0. 3 minus 1 is 2. X. And then 4 minus negative 2 is a 6, right? Plus 6. All right. In order to solve this one, we're going to have to take an extra step here and move that 6 to the other side. So subtracting 6 from both sides, I'm left with 2x equals negative 6, in which case x would have to be equal to negative 3. And again, once I know that, I can start to solve. Okay, so negative 3, we're just going to pop that into either one of the equations. Negative 3 minus 2 is negative 5. Okay, so just pick whichever one's the easiest for you to work. Okay, and there's our solution. All right, just a couple more just to kind of show you what we got going on here. And then we'll look at some interesting examples. All right. So example number 3. All right. 4y equals 2x minus 8. And then we've got, let's see, negative 4y plus 5x equals 20. Okay. And so we've got these two here. It looks like we are ready to go. But the simple fact is we're not. Okay. For this one, right, I've already thought about it, and I know I want to add those two y's together because 4 and negative 4 added together give me 0. However, right, you'll notice, right, we're not in alignment yet. Okay. So we've got to change this to bring it into alignment until we can add and subtract them. So what I'm going to do, right, is I'm going to move that 2x to the left, right? So I'm going to move it this way, which is going to bring my equal sign over. So I've got 4y minus 2x equals negative 8. And then the top or the bottom equation is just going to be staying the same because now, right, I am in alignment. Okay. I've got my equal signs on top of each other, constants, x's. Okay. And for this one, right, I've already decided I want to add them. Okay. Because 4 plus negative 4 is 0. Negative 2 plus 5. Okay. Negative 2 plus 5 is 3x. Okay, and then negative 8 plus 20 is a positive 12. So then you end up with x equals 4. All right, I already know x equals 4. So that's part of my intersection. I just need to find the other part. Now, always, when you go to find your second solution or your second part of your point, always go back to one of the first equations, okay? And that's important because if you don't do that, maybe you made a mistake in here and it worked out to give you an x value, but then when you substitute back here, you're just going to make it even messier. Okay, so go back to an original. For this one, I've got 2 times 4, which is 8. 8 minus 8 is 0. And then I've got 4y equals 0. That's what I'm thinking about here. And that's, while it looks funny, that's mathematically, definitely possible because I still need to divide by 4 on both sides. And I know 0 divided by 4 is 0. Okay. And just to check that, right, you could go back to your other equation and make sure that that works out. So if I put 0 in for y, I get 0. 4 in for that with the 5 is 20. 20 does in fact equal 20. So I know that one's good. Okay. So let's look at just a couple more, just so that we can get a little bit of each example here. We've got 3x minus 4y equals negative 10. And then I've also got 3x minus 4y equals negative 13. Okay. Now this should be an alarm for you that you see all of these the same, but we're not just looking for that. We want to go through the process here. They are lined up. Okay. And I see the 3 and the 3. So I'm going to subtract. Okay. So 3 minus 3 is 0. Negative 4 minus negative 4 is 0. So essentially I have nothing left on the left side here. Negative 10 minus negative 13 is a positive 3. Okay. And right, these two are not equal, right? So 0 is not equal to 3, never is, never will be. And so in this case, right, we have no solution. No solution. Okay. All right, and then lastly, okay, we've got example 5. And since you maybe already know where this one's going to go, but that's okay. Let's work it out. Let's put some notes down. Let's see what happens so we can get a good idea. So negative y equals 2x plus 10. All right. So again, I don't have anything lined up. It's all over the place. I need to switch this one around. So I can choose to do however I want to. I can move the 2x to the right, which I think is what I'm going to do on the top. So for the top, y equals negative 2x minus 10. This one's going to stay as negative y equals 2x plus 10. Okay, and so looking at this one, right, I know I can add these two together. So I've got 1 and negative 1. So I'm going to add here. And I've got negative 1 and 1 combining to be 0, right? Negative 2 plus 2 is 0. Negative 10 plus 10 is 0. So essentially, I end up with 0 equals 0, which is always the case, right? 0 equals 0 is always the case, in which meaning we are going to have infinite solutions. Okay, so this is just day 1. I'm going to post a PDF document just for some practice with day 1, so that you can just get a feel for solving these problems. And then day 2, we're gonna get a little bit fancier with this approach and see where we're at, and there'll be a little assignment to go with it. All right. So any questions, comments, concerns, guys, just shoot me a message. If not, have a great day, and we'll see you tomorrow. Thanks, guys.